Page 149 in your student journal, we've kind of dealt with this stuff, but it's just to kind of emphasize and summarize, emphasize the important parts and summarize what we've done over the last 3 lessons. 3 ways to solve systems using substitution, elimination, and the first way was graphing. And that graphing process shows us the different types of solutions we can have. And we've talked a lot about when 2 lines intersect at a single point. That single point is the solution to that system of linear equations. However, there are times when you're dealing with linear equations where the lines won't cross. And when they won't cross, you don't have any solution because there's not a single point that makes both equations a true statement. Okay? And sometimes the lines are exactly the same. They're identical. You get infinitely many. Now that's easy to see in a picture. If I said this is a system, what's the solution? Yeah, well, you only see one line, so it has to be infinitely many. It means both lines are the same. They're lying on top of each other. Versus, what's the solution here? Well, it's no solution because they don't intersect. And here, it's one solution. The difficult part could be when you actually see these in equation form to tell. All right, we've done a lot of work with this one where we get a single point as a solution. Okay, we've done some work with these we've seen. So what I want you to do right now is any method you want, whether you want to use substitution, elimination, graphing. If you have graph paper or need graph paper, you use that. But any method you want, I want you to solve problem number 1, number 2, and number 3. Okay? You work with your groupies, 1, 2, and 3 right now. All right? Go for it. Brief review. How many are using substitution on number 1? How many are using elimination? How many are using graphing? Okay. It's one of the 3. How many use substitution? So no one's using substitution. How many are using elimination? Raise your hand really high if you're using elimination so I can see it. Okay. How many are using graphing? Really high. All the way. Okay. So graphing works. Graphing takes a little longer. Probably out of all those 3, just a quick review, I'd end up using substitution. This plugs in for that. If y equals this, we put it in for y right here. Yeah, me too. That's why I showed it. All right. Probably the easiest method, but you can use any of the 3. All right. We got about substitution. All right. So I've got Jaden's here. She's used substitution. So Jaden, do you mind if I sketch in this one? All right. So we've got 3x minus 7 equals 3x plus 4. So she's plugged this piece in here. And so the 3x plus 4 equals 3x minus 7. Added 7, we get 11. Very good. So we get 3x equals 3x plus 11. Subtract 3x. And we get that canceling. So we end up with 0 equals 11. Can 0 equal 11? No. So a note you should make in your folder is anytime your variable disappears and the statement is true, or is false, that means it's no solution. Anytime your variable disappears and the statement is false, it's no solution. Jaden, very well. All right. Everyone thanks Jaden. 1, 2, 3. Oh, that was kind of a weak thank you. 1, 2, 3.
Thank you.
That was bad. Some of you are like, hey, Jaden. Man, that's tough. All right, Jaden, well done. All right, who's got number 2? Anyone want to try 2? Oh, come on, dude. It's because that's all right. Gives me a chance to teach.
You can't really see my work.
Where is it?
Well, I've written in
Jeez, invisible ink?
I don't think I've written it.
Anyone want to try it? Can I borrow? Can I borrow? All right, I will borrow Katie's. All right. We can't see it, so as long as
You can't see it, but you can see the answer.
I will try to decipher Caden's work. I will try to translate.
I think it's
All right. So, Caden, did you use elimination?
Yeah.
Okay, so subtracted 5x. We get negative 5x plus y equals negative 1 from the first equation. So this became that, correct?
Yeah.
Okay, and then added 5x. So we get 5x plus y equals 5. So that one became that, correct? All right. Those are both accurate. And then you added the two equations up. So we get negative 5x plus 5x is 0. Y plus y is 2y. Negative 1 and 5 is 4. 2y equals 4. Divide both sides by 2. Y equals 2. You plug that 2 back in to the second equation. Did that right here. So you put the 2 in right there. 2 equals negative 5x plus 5. Subtract 5. Divide by negative 5. X equals 3/5. And you get the ordered pair 3/5 2, which is correctamundo. Well done. All right. How many solutions here? Will these lines cross? Remember, let's go back to this page right here. Which picture does that look like? Is it a one solution, no solution, or infinitely many? It's one solution. They cross at the ordered pair 3/5 2. That would be our point of. Now that's not this picture obviously, but they cross. Versus the last one where we had Jaden's, that was a no solution. Those lines never will cross. Okay, very good job. Any questions so far? All right, who's got 3? Number 3. Anyone have 3? You got it? Can I borrow it? All right. Everyone say thank you, Katie. Well, that was a little better thing. At least we didn't have people groaning. Thank you. Let's see. All right, so Annalise, did you use elimination here? Okay, so you added, and we get 2x plus negative 2x gives us 0. Negative 3y plus 3y gives us 0. And 10 plus negative 10 is 0. And if all the problems were that easy, that'd be great. Right? You get 0 equals what? 0 equals 0. Is that true? Is there ever a time that 0 doesn't equal 0? No, that's always true. So notice in this one, your variable disappeared, and you have a true statement. That's much different than over here where the variable disappeared and you had a false statement. Okay, this one's false, this one's true. This is no solution. This is actually called infinitely many solutions. Okay, so they look very similar with the exception, with the exception that this one becomes false, this one's true. The variables disappear in both, but if it's false, it's no solution. If it's true, it's infinitely many. Picture-wise, remember, that's the difference between this and this. You'll notice in this one right here, these equations they're very similar to each other. Okay, 2x minus 3y equals 10, and negative 2x plus 3y equals negative 10. If I multiplied this bottom one by negative 1, or divided it by negative 1, I would get that exact equation up there. That means they're the same line. Okay? All right. Any questions there? Okay. Hey, one other thing on number 1. Let me put up what I had here. This was my work. I just didn't want to show my work, but there's my work. Number 1, I want you to take a look at that. Tell your neighbor what no solution lines look like. Some of you have said it. What do they look like?
Parallel lines.
They're parallel lines. What do you know about parallel lines? We talked about it last chapter. Yeah? They never cross. What do you know about the equations? Remember, parallel and perpendicular. What do we know about the slopes? Yeah?
Those slopes are the same.
Slopes are the same. Now look at this. If you would have recognized right away this is y equals mx plus b, notice m. Slopes are the same. B's are different. These are parallel because our slopes are the same. If you have it in slope-intercept form, which we have those both in, and the slopes are the same, you automatically know they're parallel. And if you recognize, hey, parallel lines are no solution, then you're good there. Okay, so if I were to say, I don't know if I have any of these others in slope-intercept form, but which other ones look like they might have the same slope on 4 through 9? Go ahead and circle any that you think might have the same slope. All right, does anyone have one? Yeah? Number 8? What do you think?
5.
Number 5? Okay. Any others? Yeah? Number 9? All right. 8, 5, 9. I will tell you that all of those have the same slope. Now, just because they have the same slope doesn't necessarily mean they're no solution. They could also be what? Infinitely many. I mean, they could be the exact same line. Right? If I look at this one, these numbers all look very similar. Right? In fact, this one's positive, that one's negative. This one's positive, that one's negative. This one's positive, that one's negative. When I add them up, I get 0 equals 0. What is that? Infinitely many. Of course, a line's going to have the same slope as itself. Okay, so you're right, this would have the same slope. Infinitely many is not always that easy to find, though. Yeah?
How come on number 3 it did like the same thing?
How come on number 3 what?
Oh, it was number 3.
Yep.
Oh, never mind.
Okay, how about 9? You look at it, 3 and 9, 2 and 6, 6 and 18. This equation right here on top, if I multiply this bottom equation by what? By 3. If I multiply that by 3, notice I end up with that top equation. Okay, this becomes, well, I almost end up with it. I end up with its opposite. This becomes this becomes 9x, negative 6y, and 18. Notice now, if I add those, I get 0 again. 0 equals 0. This one is infinitely many. All right. How about this one? Infinitely many or no solution? Looks like I could double this to get that. Or, excuse me, double this to get that. Multiply by negative 2. Can I multiply this by negative 2 to get that? That's cool. How about this? Yeah?
No. Yeah.
Signs are different. Times negative 2 times negative 2 times negative 2? No? Who says yeah? Who says no? Okay. Yeah, this one has to be a negative for that to work, right? So if I were to multiply this out, if I were to say, well, I'm just going to double the top equation, you could do that. You could multiply it by 2. That gives you 8x. That gives you 6y. It gives you 34, except for this piece cancels that. That becomes 0. That cancels that. That becomes 0. This becomes what? 68. Now you have 0 equals 68. Is that true? No, that's never true. What's this one? This one's a no solution. There's one more up there that would have the same slope that we haven't done yet. Okay. Go ahead and tell your neighbor which one you think it is. I have a reason why. Let's take a vote. Who says number 7? Okay. Close. Who says 6? No one says 6. Poor 6. Okay, 1 says 6. Thank you for making it out feel bad. Okay, who says 4? A couple of you. How come everyone said 7? Just out of curiosity. Like, what makes you think 7's going to have the same slope? I'm not saying you're wrong or right. I'm just saying. Yeah? Because the y's are the same? Is that what everyone's thinking? Slope is y over x, right? So really I'd have to move that 2x over, and then I'm going to divide by that 3. So when I move this 2x over, it becomes positive 2x, right? And then I divide by 3 here. When I move that 2x over, it becomes negative 2x divided by 3. So these aren't the same right now. That's a positive 2 and that's a negative 2. So this one is not going to have the same slope. They'd have to be opposite coefficients. Boy, what do you think, TT? You're going to say 4? Trinity, you're going to say 4? Are you guys saying that? Why are you saying that? Go ahead. Good. If one's positive, the other's negative. Is that what you're going to say, TT? The other thing is if you add them up, we get 0, we get 0, and we get 9. These lines are parallel. 0 cannot equal 9. This is a no solution. Okay. So hope we've shown, the goal was to show when you're going to get infinitely many and no solution. Okay, looking at it in equation form. Hopefully you can you'll recognize how those tie to the picture. Okay, remember these have the same slopes. All right, so do infinitely many. The only difference is one of the lines have different y-intercepts. Okay, the no solutions do. All right, our assignment today is going to be a review. Let me get you that here. All right, hey, let me have your attention back up here real quick. Your assignment today is a review. You'll get a practice test tomorrow. Okay? So what I'm expecting is that you can go through and be able to graph, use substitution, and use elimination. Be able to do that efficiently for your test that's coming up. And I would like you to be ready for that on your practice test tomorrow. So you've got the front page here. Looks like we've got 12 problems on there. And then the back page, we've got a chunk of problems. On the very last part here, you get to choose. Use what's most efficient for you. If you like elimination and it's set up well for it, use it. If you like substitution, it's set up well for it, use it. Okay, I doubt many of you will graph, but if you want to graph, you can get graph paper for it. Okay, number 17 is kind of, I think it's number 17. Let me see. Number 17 there is a little tough because you can't see the number. So let me tell you that number there. That's x plus 4y equals 12. Okay, so fill in that 2 right here if yours is messed up. So this number right here is a 12. Okay? So everyone has their stuff. You can work quietly on it. The answers are hanging up there so you can check them out. Okay? Use your time wisely.